Hello everyone, my name is Avant Mehta and today I'm working on ABE425 Lab 9, which is Introduction to LabView, and we're going to have quite a bit of a look at the temperature data, the data acquisition, data processing, and presentation of the results. So let's get into the block diagram, which is the back end of what happens in LabView. And over here on the top left we have the DAC assistant. Over here we have the calibration. There's a constant of 100 over here, which gets added to the calibration knob value, which goes from -1 till +1. And that means that when it gets added together, the range is actually 99 till 101. That value gets multiplied with the output from the DAC assistant, and then 273.15 is subtracted from that to convert from Kelvin to Celsius. And then the Celsius output gets outputted to the temperature reading, both the temperature scale value as well as the numeric reading. It gets converted to a double. In the function block, we have a Fahrenheit value equals 1.8 times Celsius value plus 32. And then we have the Fahrenheit output that gets outputted to the Fahrenheit scale value as well as the numeric reading and the temperature sensor graph. And we have the time controller over here. It makes sure that it takes data at every correct interval of time, and then it's merged together. It's written to the measurement file, and we have trackers of the elapsed time. And of course, we have the entire thing is in a while loop block, the stop button of which is attached to the end of the while loop over here. So that controls the stoppage of the while loop. Now, we'll go into the front end of the app. We have the calibration knob, which I can turn, as I said, from -1 till +1. The volts meter is there side by side with it. We have the Celsius and Fahrenheit readings, both in numeric value and with the scale. For Celsius, we've put the limits as 0 and 100. For Fahrenheit, we put the limits over here as 32 till 122. And I can play around with the calibration to show you what happens. For the most part, it's like as time goes by, the amplitude goes from about 68 till about 80. And that's what we have on the front end. I can stop it over here, and I can jump to the questions which we have to answer for the day. So first we have the International Temperature Scale of 1990 defines several triple points that can be used for temperature calibration, and find the two closest to the triple point of water, which is 0.01 degrees Celsius. So if you look over here, the Wikipedia page for International Temperature Scale of 1990, if you look at the triple points, the closest to 0.01 is the triple point of Mercury, which is -38.8344. And we have the triple point of Argon, which is -189.3442. Those two are the closest triple points to that of water. And the second question we have, if the voltage drop across the 135 chip is 2.7 volts, what is reasonable value of the resistor to limit the current to 0.4 milliamps? And for that we use Ohm's law, as you can see here, which is V equals IR. And we mix it up to make resistance the subject. So R equals V over I, voltage over current. Replace the values we know, 2.7 volts and 0.4 milliamps, which is 0.0004 amps. And finally, we get resistance is 6,750 ohms. And the third question is, what is the current SI definition of temperature, and how will it be defined in the future? So as we know, temperature is basically a measurement of the average kinetic energy of the particles of a substance. And if you look over here for the SI base unit, the Kelvin, symbol K, is the SI unit of thermodynamic temperature. And it's defined using the Boltzmann constant K, which is 1.38 times 10 to the -23rd. And of course, we know the Celsius scale is basically based on the Kelvin scale, but with a fixed value offset. And how will it be defined in the future? I think this one comes down to a matter of speculation, if anything. I think that the definition is pretty solid in terms of being precise enough that it doesn't have to be edited. So how will it be defined in the future? I think it'll stay as it is for some time at least. And that brings me to the end of the questions and the lab for the day. And as always, thank you so much for watching my video. Have a good one.